So in this lesson, we'll study about the transition curves and the essential requirement of a ideal transition curve. Okay. So to get started with, we already have seen in the previous lesson what is a transition curve. It's also known as what? Easement curve, where the radius gradually varies from infinity to a finite value. Okay, the finite value is equal to the radius of the circular curve. Right. So this may happen from tangent to a circular curve or from a circular curve to a tangent or vice versa. Normally, why we give transition curve is for a ease and gradual change in direction. Now, in detail, let us see what is the objective of providing a transition curve. Right. So the first one, as we already mentioned, is to provide gradual change in the radius of curvature from infinity at tangent to finite value equal to r at circular curve and vice versa. Right. So this we have already discussed, so I'm not going in detail with that. Now the second one is to provide gradual increase of super elevation to the outer rail. So we know that for the tracks in the curved portion, we provide super elevation, right? So super elevation also should be provided gradually so that there is reduction in shock or any severe jerk onto the moving railway vehicles. So for that also we need transition curve. So to provide gradual increase in super elevation of the outer rail with respect to the inner rail to avoid what? Shocks and severe jerks. So for this reason also we have to provide the transition curves. Then the next third objective is to minimize the wear. So we know that the railway tracks are going to wear, especially in the curved regions. So in order to reduce the wear in the curved portions, we have to go for the transition curves. Next, the fourth one is to provide a safe movement to the trains, right? And then the last one is to provide a comfortable journey to the passengers due to smooth running of the trains. Now, for all these objectives, we need to go for the transition curves, right? Now, let us see what are some essential requirements of an ideal transition curve. So, if we say a transition curve is ideal, what all it should have? It should majorly have four things. The first one is what? The radius of the curvature. The radius of the curvature should vary from infinity to r at the junction of the tangent and the curve. So if this is a regular curve and this is a straight, it should vary from infinity to r and vice versa. That is your first requirement of a transition curve. Then moving on to the second requirement, it should meet the straight and the circular curve tangentially. So whenever a circular curve and a straight is met, it should meet it tangentially. So in no other direction it has to meet. Okay. So meet tangentially is your next requirement. Next, moving on to the third requirement is regarding the length of the transition curve. It should be in such a way that full super elevation is obtained at the junction with the circular curve. Okay, so length should be in what manner? It should obtain full super elevation at the junction. So these both points are at the junction of what? Straight and the regular circular curve. Next, the fourth essential requirement is that the rate of increase of curve. So rate of increase of your curvature, rate of increase of curvature as well as of your super elevation, these both rate of increase should be same. So if it has different rate of increase of curvature and super elevation, then the transition curve is not perfect. Okay, so these are some of the essential requirements that a ideal transition curve should have. Hope you have understood it. Thank you.